Uh, our first presenter of this last session of this conference, Lakshmi is Kululi Manvi Grover Ayush Chaudhary, and they are going to present the paper titled Priority Based Signaling System for Ambulances Using GPS IoT Computing. Please assert yourself if you're present.
Hi, ma'am, we are present. Title Priority Based Signaling System for Ambulances using GPS, IoT, and Cloud Computing. This paper is presented by our faculty, Assistant Professor Bhagyalakshmi S. Kololi, MVJC, Bangalore, India. My batchmate, Ayush Chaudhary, MVJC, Bangalore, India, and myself, Manvi Grover, MVJC, Bangalore, India. So let's get into the problem statement. Vehicular traffic is endlessly increasing in the world, and this can cause terrible traffic congestion at an intersection. Most of the traffic lights today feature a fixed looping light sequence and do not take the presence of emergency vehicles in vicinity into account. Therefore, emergency vehicles like ambulances, police cars, fire trucks, they tend to get stuck in traffic jam, and this in turn delays them in reaching the destination, which can lead to loss of property and lives. So the focus of this project is to reduce the delay in arrival of an emergency vehicle to its destination by automatically clearing the lane traffic. In the entirety of this presentation, we have assumed the emergency vehicle as an ambulance and the destination as the hospital. Now, there has been extensive research conducted to solve this problem. Technologies like infrared and global positioning systems have been used extensively to detect the emergency vehicle. RFID tags have been used to identify emergency vehicles, and the inductive loop method is used to count the vehicles on the road. Wireless sensor networks allow for embedded sensors to be connected in an array formation for observing and controlling any type of devices. There has also been use of emergency vehicle preemption system designs, which includes strobe light systems, infrared emitters, acoustic systems, and radio-based emitter detector systems that solve the same problem. Use of VANETs has also been done, but we are using, our approach is a little different. We are using cloud computing, GPS, and IoT to address this problem. Now, the major crux of this project is that the ambulance will be embedded with a GPS and Wi-Fi system, which will facilitate the vehicle's real-time location tracking, and it will share its coordinates to the cloud. For this project, we have taken AWS as, we are using AWS Cloud. So the ambulance will be provided with an emergency button, a push button, which will be in complete control of the driver. The driver will estimate the traffic near the signal using Google Maps, and he will decide when to press this emergency button. Upon pressing this button, the Lambda function in the AWS cloud will get triggered, and the live coordinates of the ambulance will be sent to the cloud. The Lambda function here in the cloud is basically responsible for three things. First, it calculates the distance between the ambulance real-time coordinates and the nearest traffic signal. Second, it persists this data in a database. We are using AWS DynamoDB here in this project. And third, it sends that information to the microcontrollers in the nearest traffic signals of the ambulance. The microcontroller will accordingly send the information to the traffic signals, which will take instructions and allow the lines for the ambulance to pass. Right. So we are using Haversine formula to calculate the distance between the two coordinates. This is the formula that's present in front of you. Here R is the radius of the Earth, which is 6371 kilometers. Phi is the latitude of the 2 points, and lambda is the longitude of the 2 points. So using this distance, we are calculating, using this formula, we are calculating the distance between the coordinates of ambulance and the nearest traffic signal. Now, the minimum distance recorded is an indication that the vehicle is closest to the junction. When the ambulance is approaching the signal, the distance is increasing with time. And as it crosses the junction, the distance begins to increase. That is a point when we know that, okay, we have to switch the lights back. The signal turns green before it reaches the minimum distance and then goes back to the old state after the distance starts increasing. This means that the vehicle has crossed the junction. This is the algorithm of the whole project. So push button, as it's pressed by the driver, live coordinates are sent to Amazon CloudWatch. It's a service by Amazon that is used to collect, access, and monitor the data. Then that data is sent to AWS Lambda, which is a serverless compute service by Amazon. It calculates the distance between the two coordinates and stores the same in the database for troubleshooting in future. Then it makes decisions and sends those updates to the microcontroller, which is Raspberry Pi, which is fit near the traffic, just fit in the traffic signals. And that Raspberry Pi or the microcontroller will send instructions to the traffic signal and it will allow lanes to pass. So this is a small pictorial representation. If there's only one ambulance, then the other lanes are put at halt and this lane is allowed to clear. If there are more than one ambulance at a junction, then the decision is made with distance. So here in this figure, you can see there is one ambulance here and there is the second ambulance here. This ambulance is closest to the junction, so it will be allowed to pass first. And then the other ambulance, and then the second ambulance, which is a little far from the junction. This will be given second priority. And then the final priority will be given to the other lanes. So the entire system is automatic. Manual effort is required to clear the road during emergencies. The database in the cloud that is maintained, it helps to troubleshoot the system and identify the loopholes present. Now, although the control of this whole, the initiation process is in the hand of the driver, but this is just done to decrease the complexity of the system. However, it can be overcome by calculating the traffic density using wireless sensor networks or other density detection techniques, which will automatically drive the traffic away before the ambulance arrives at a junction without having the driver to use any button. This priority signaling system, when properly designed, operated, and maintained, will yield significant benefits like reduced waiting time for emergency vehicles, saving fuel consumption, and preventing loss of life and property. These are the references that we use to design this paper. And thank you so much for giving us this opportunity to present in this conference. Back to the host.
Presenter is now open for question answer session. Any queries from the audience is most welcome to the presenter. With that, we move on to our next presenter, Dhaval Sahija, and the title to be presented is usual.
So thanks. Okay. All right. So thanks for providing me an opportunity to present this research paper on user adoption for augmented reality and mixed reality for manufacturing vertical. I'm presenting this paper in International Conference on Science, Engineering, and Technology Innovation. And I'm thankful to all the organizers, including Research Cultural Society and various organizers mentioned over here. A little background about myself. My name is Dhaval Sahija, and I've been working as a subject matter expert and solution manager for augmented and mixed reality technology in various digital agencies across New York, Dallas, and India. And prior to this position, I have worked into various roles, including business strategy, technology consulting, and digital innovation lead for various verticals, including engineering, healthcare, oil and gas, and so forth. Okay. As far as this research paper is concerned, that is user adoption of augmented and mixed reality for manufacturing vertical. What I would like to showcase is that based on the overall evolution of the technology in manufacturing vertical that has happened for last or 3-4 decades, up until from some legacy technologies such as SAP, until to automation systems and industrial 4.0 and cyber physical and so on. Over the period of time, all this technology advancements have supported in upgrading and updating the capabilities of manufacturing processes. But still, we see that even after all those advances, there are still so many gaps. There is still a lot of scope to improve the productivity, to improve the efficiency, and to further improve the automation in various manufacturing processes. So what we are doing over here is that within this research, we are trying to explore as to how augmented and mixed reality technologies can be used to overcome these gaps. And over here, for the research, we have used a solution around HoloLens, that is a mixed reality headset by Microsoft. So we have used this solution to see as to how we can overcome these gaps by doing research and surveys and implementation in local manufacturing facilities over here in Texas and Texas, USA. So not only we have tried to find those gaps in various processes, but how we can fill up those gaps and how augmented reality and mixed reality can support it, and what are the outcomes and what are the findings and what are the implications of it. That is something that is presented into the paper. Now, if you see over here, various manufacturing companies, they are facing various kind of bottlenecks, such as how they can further automate some of the manual processes that they have in place, how they can decrease the dependence on existing workforce. Because what is happening is that the with the iteration of workforce and with workforce changing, various organizations and so on, the manufacturing companies have to find out ways as to how they can decrease the dependence if in case the existing workforce retires or is not available for the work and so on, or if in case there's a time span in which the existing workforce that belongs to the previous generation, how they can do the knowledge transfer to the current generation, which is more technology and gadget savvy, right? Apart from that, there are also issues pertaining to how they can further improve the productivity within the existing processes and how they can further improve the automation by using these technologies. So, to achieve these objectives, we have obviously done rich literature review of various authors and various scholars who already done research in these areas. And what we have found based on the literature reviews that many of the manufacturing and engineering companies, they're already doing various kind of experiments. They are doing proof of concepts. They're also doing prototyping into various departments, into various processes within their manufacturing facility and within their factories, including their supply chain processes, their product design processes, their marketing and sales operations, and also to a certain extent into their customer service. But what we have found based on this literature review is that even after doing certain amount of experiments, they are still facing some challenges and they have limited amount of success. So what we are trying to do over here in this research is that we are trying to find out what are the factors that are limiting the success of adoption of augmented and mixed reality technologies. What are the challenges in implementing and how we can overcome them. Okay. So to do this research, we have used secondary data collection by reviewing various publications, various research papers, various review articles, various technical and trade documents that are publicly available. Apart from that, we also leveraged various kind of historic and statistical data that is available in public record to conduct our research. So further on, I will, in the larger interest of time, I will jump on to the findings. So if you see the key findings, these are the various factors that are impacting the user adoption, meaning that these are the factors because of which manufacturing companies and engineering companies are not able to fully use or fully harness the capabilities of augmented reality and mixed reality technology. So one of the key factors is legacy infrastructure. What is happening is that existing IT infrastructure that they have in place, it is very old in nature. It supports legacy systems such as Windows 10, such as SAP, such as DOS, and various legacy ERPs such as PeopleSoft and Oracle and so on. So because the overall infrastructure is very legacy in nature, it is not because of that they are not able to integrate this modern technology and tools. Apart from that, there are many technicians and there are many factory workers They are pretty used to using the existing technology. Now, since they're using this existing technology for pretty long time, they're not ready or they're not willing to adopt these new tools. And then there are certain factory workers that belong to a new generation, which are very gadget savvy. They can immediately start using this technology and tools, but still there's not enough awareness or not enough training available so that they can start adopting it. Furthermore, there is also limitation in terms of scalability of the existing systems. So when I say existing systems, it is pertaining to control systems, it is pertaining to PLCs, it is pertaining to SCADA. Now, all these systems, they're obviously, when they were implemented for a different objective or a different purpose. Obviously, they were not implemented for integrating with augmented and mixed reality headsets and tools. So, in that sense, there is also a need to further scale up these systems so that they can be adopted with these tools. Last but not the least is the high implementation cost. Now, there is a common perception that the cost of the gadget is very high, and then you need cloud consumptions, and then you need third-party tools and components, development components, and frameworks, and so on. So, because of this lack of awareness and limited information available, the perception is that the overall implementation cost of these solutions is pretty high, which is not exactly true, and that is something that I will talk about in the session ahead. So based on the research, what we have done is that
You're left with 1 more minute, sir.
okay, all right, I'll come up to speed. So based on the research and based on the findings, these are the following outcomes that we have as to how we can drive the user adoption of augmented and mixed reality headsets among engineers and technicians within factory. So one of the key things that we can do is that we can provide them technical awareness and technical documentation so they are better prepared to use these tools. Apart from that, we can provide them a very user-friendly interface so that it aligns with their existing work environment, it aligns with their existing processes, so that they are ready and they can easily use the existing these modern tools. Furthermore, we can look at ways as to how we can do the integration of these systems with their existing control system, so that engineer is pretty aligned and he can easily start using these tools. Apart from that, we can also look at ways as to how we can do the integration with their existing databases, with their existing IT servers, with their existing cloud systems. So because of that, they don't have to end up like removing or scrapping the entire existing infrastructure. Rather, the systems can be easily aligned and integrated with existing infrastructure. Now, with these outcomes, following on the implications and conclusion that we have, now post adoption of this technologies, what we have seen is that it will further improve and enhance the automation of step procedures by digitizing the procedures by using voice commands. So they no longer have to use hands or manuals to achieve to do this task procedures. They can easily use voice commands. They can easily fetch historic information within their augmented reality headset interface to finish their task. And it would overall improve their efficiency because all these headsets they provide very hands-free experience, so that engineers and workers they can collaborate from different locations, from different factory sites, and so on. Furthermore, they would be in a position to easily do the decision making by fetching the historic data of issues that were resolved in past, availability of part number, and also they can they can easily do decision making in terms of production planning, configuration, and assembly line, and so forth. Yeah. All right. Uh, yeah. So I'll keep this forum and discussion open if in case someone may have any questions pertaining to this technology and how we can drive the user adoption in manufacturing vertical. Yeah.
So any question from the audience? The presenter is open. Well, a very nice presentation. So with that, we move on to our next presenter.
Thank you, Dhaval.
Oh, okay. Thanks for your time. Yeah. All right.
Good afternoon, all. I am Dr. T. Lakshmi Bal of Sri Chandrasekharendra Saraswati Vishwamahavidyalaya University, Kanchipuram, Tamil Nadu. I thank authorities to share my ideas in this conference. My topic is mathematical modeling and analysis of VSI fed induction motor drive using PSync software. This is my lecture flow. First, I'll discuss the introduction, objectives, and mathematical modeling of induction motor drive and VSI, and about the software and working model, etc. Introduction. Almost all industries use induction motor with variable speed drive for their applications. Three-phase induction motors are well suited for all the loads, both for constant speed as well as the variable speed. The speed control method for three-phase induction motor can be done by using the power electronics inverters. The objectives are: the mathematical model for adjustable speed induction drive fed from voltage source inverter was designed, and the performance was analyzed by simulating by using the PowerSync software. The stator voltage control method is used for controlling the speed of the induction motor, which is achieved by PWM VSI. Simulation results are attained by using PSync software for the efficacy of proposed model. The performance analysis of this motor fed by VSI is done, and it is simulated by the simulator, and the findings are three-phase currents, three-phase voltages from the VSI, and as well as the torque and speed waveforms. First, before entering into the topic, first we have to note what is electric drive. In industrial application, production unit consists of three components. The number one is the electric motor, number two is the transmission device, and number three is the working machine. Motor, which is nothing but converting the electrical energy into mechanical energy, that mechanical movement which is to be supplied to the working machine, that is nothing but load, and the supplied machine is nothing but the energy transmission device. So the motor is the source of motive power, and the transmission device delivers the power from motor to the load. The load may be shaft, belt, chain, rope, etc. Working machines are nothing but lathe, centrifugal pumps, drilling machines, lift, conveyor belts, food mixers, etc. So the electric motor along with the transmission device is called electric drive. And if we add the working machine into it, then this is called electric drive system. In this slide, we can able to distinguish what is electrical drive and what is electric drive system. Here, this figure which depicts the power controller for motor, and then this is the energy transmission device. This three together, which is called electric drive. If we add the load into this, this is called electric drive system. So here we can see the example. In the first example, the ceiling fan motor along with the speed regulator without blade is called electric drive. If we add the blades, then this is called electric drive system. And for the second example, the food mixer without food to be processed is called electric drive. If the food is to be processed is added with the food mixer, then it is called drive system. And in the third example, conveyor belt without any material on its belt is called electric drive. If the material is added on the belt, then it is called the electric drive system. And here the mathematical modeling of induction motor is given. Here I am taking the three-phase induction motor, that too the squirrel cage induction motor, and there are two varieties of motor. According to the construction of the rotor, we can classify into squirrel cage induction motor as well as the wound round motor. But here I am taking the squirrel cage motor. These are the attributes which here used for mathematical modeling. The resistance and the inductance of stator side is noted, and then the attributes of rotor side, the resistance and inductance are shown here. And this is the magnetizing resistance inductance and the turns ratio NS by NR, which is given here. Like that, all the attributes which can be used for mathematical modeling. This is the mathematical equations for induction motor modeling. And I'm skipping here. And then this is also the mathematical modeling equations, and the mutual inductance between stator and rotor winding is given. And then the magnetizing inductance is given by this equation, and the mechanical equation as well as the torque developed, which can be given here. And this is what the modeled induction motor, that is the equivalent circuit in terms of the rotor side and the stator side. This is the stator side and this is the rotor side. And here this is the resistance which can be indicated with the S. S is nothing but the slip. And here in the voltage source inverter, the relation between the resistance and the temperature is given, and for the switching, the gating block is used. And this is the gating block which is used to supply the VSI, that is voltage source inverter. Here we can able to see the voltage source inverter circuit. Here the MOSFETs are used as a switch, and here the input is supplied with the DC, and here we can able to get the AC. And for getting the AC, converting DC into AC, how we can proceed is the switches we can able to give the proper triggering angle. So first 1 and 2 will be triggered, and then after certain period of time, that is after certain phase angle, the 3 and 4 will be triggered in order to get the B phase, and to get C phase, the 5 and 6 will be triggered. So by proper triggering, we can achieve the 3-phase output. And for getting the 3-phase output, this gate switching block is used. So here in this gate switching block, here there are, if you are using this switching for a period, first period, then we have to note that how many switching points are used. So here the 6 switching points are used. So the N is the switching point, number of switching points, and then the switching angle we can able to note in this table. So the frequency we can use is 2000, and the number of points is 6, and the switching points are the 35, 92, like that. And the basics of PSIM. This is the software here we are using. Here this is having the 3 models. One is the PSIM schematic. Here we have to draw the circuit, and after drawing the circuit, it has to be simulated by using the simulator. After simulated, we can able to see the waveforms by using the SimView. So the along all the 3 together, we can able to use for PSIM software. Here the PSIM software circuit, it is shown, and in this software, here all these things are given. And if we want to draw the circuit in this worksheet, here file, we have to click the file, and if already the circuit is available, we can choose it. Otherwise, we can able to choose the new file, and then we have to draw here. For drawing here, all the elements are available. We can choose from the library. This is the library. We can choose from the library. We can able to take the component device from this, and we can able to draw here. Otherwise, from this one for elements, and we can able to choose any power device or control device or sources. Here source is selected, and the voltage or current which we want, that we can able to select. Otherwise, we can able to select from the bottom side also. And after drawing, we have to simulate. So here the simulate button is there, and then by using the simulate button, if we click this, we can able to have the simulator. Okay. So after simulating, the waveform will be shown by SimView. And this is the procedure I have already told. This is the working model. Here the VSI model I have given in as a block. So the circuit already we have discussed that. And this is the induction motor, and the VSI is the inverter circuit which has the input of DC and converted into AC, that is applied to the AC induction motor. And then what we are doing is here the voltage is varied, stator voltage is varied in order to get the speed. So that stator voltage variation we can able to get by the varying the triggering angle by the gating block to the VSI. And here the voltages are taken in order to see, and the 3 currents each phase, that we can able to see. And then here I am connecting the speed sensor as well as the torque sensor. These two we will give you the speed and the torque waveforms. This is what our input waveform, that is the constant voltage DC voltage is shown, and this is the output waveforms. 3 output waveforms we have shown. This is started in the positive side above the 0, and this is exactly started at 0, and below 0 in negative point it is started. So 3 phase voltages we have taken from the output by simulating the circuit, and here the current waveform is shown. So this is combined current waveform is the first figure, and individual currents will be shown in the next figure. And the output will be the torque waveform as well as the speed waveform. We can able to see here. The simulated output will be shown in this diagram. And conclusions. The proposed model was designed and tested by the PSIM software, and the simulation results. Is it audible, ma'am? Is it audible?
Go ahead.
Yes, it's audible.
Yeah. So the proposed model is designed and tested by the piecing software. Simulation results illustrates the performance and effectiveness of our design VSI fed induction motor drive. Here the starter voltage varied for varying the speed of the motor, and it is varied accordingly. The piecing software is the user-friendly software that eliminates physical connection of the circuit that sometimes makes the component get damaged during working. So the trial and error method can be performed to any number of times until the required result arise. Thank you.
The presenter is now open for any question.
And participants, let me introduce myself. I'm Kirti Patikumar, research scholar and Wales Institute of Science and Technologies in Chennai, and my co-author is Dr. Ari Kartika. And let me introduce my topic: a detailed analysis of stability variations in active queue management technique. It is a network-based project, network-based research paper. 1 second, sorry. 1 minute. Yeah. Coming to the abstract, the congestion is the most important topic in the networking for the researchers. Now, basically, they are focusing on the transmission control protocol. This is one of the congestion control algorithm used to ensure the stability of the entire network has been studied in the details. And active queue management is one of the best technique to control the congestion in the network. So we have analyzed the stability and variation behavior of the various AQM techniques, such as different algorithms are there. I don't want to mention all the algorithms because we have so many algorithms. So we have tested all the algorithms. So coming to the introduction part, we know that one how the internet will work. Nowadays in the pandemic, so many of them they're using internet. So mostly so many of them they're facing the congestion problem. Sometimes the network sometimes is coming, the flow was good, sometimes the flow is not good. So what is the problem? Because of the network traffic, the congestion. So how we are going to avoid that congestion using some different techniques? So that is my topic. So for avoiding congestion control, we have already one algorithm is there. There's called TCP algorithm. They're using the internet. The TCP was designed to provide reliable transmission of data. However, it has evaluated to provide the congestion control. It will control the entire system, but internet congestion control mechanism attempt to maximize the link utilization while minimizing the queue size and number of drops. So it's a queue means you can say the buffers are used to store the data waiting to be sent. When congestion occurs, the traffic will forward and it will initiate the queued in the memory of the network devices. Unless such congestion can be managed, device memory may be executed and packets arriving at the destination point. So this is you can say that simple form of the congestion. So what is the best technique to avoid? Already I have mentioned that TCP is the existing technique to avoid the congestion. But in coming near future, because so many devices are increasing, so they have found with the active queue management, this is one of the best technique in the congestion control in the network. So just you can focus on the few points in the active queue management techniques. So what will happen? So when the multiple packet loss, when low link utilization, will congestion collapses. This is the congestion control. TCP already it will control the points, and the role of the router became important. Here the role of the router is very important. The router will control the congestion effectively in the networks, and it will allocate bandwidth fairly. The problem with the current router, what is the existing technique problem? Use FIFO based trial drop queue management. The drawbacks of the management is already existing management is lockout and small number of flows monopolize the buffer capacity. The full queue, the buffer is always full. So what is the solution for that? We are proposing the active queue management technique. So coming to the active queue management goals, what is the goals of this active queue management? It will reduce the average queue length. It will reduce the packet loss. What are the methods you are using in the active queue management? It will drop the packets before the buffer becomes full, and it will use the average queue length as a congestion indicator. So coming to the already, you have so many algorithms out there. Already some of them, they have proposed some of the algorithms in the active queue management. That is random error detection, random exponential marking, and modified RIM. So these are the algorithms already they have proposed. The researchers, they have proposed all the algorithms. So coming to the literature review, after studying all these algorithms, the observations on the dynamics of the congestion control algorithms, the effect of two-way traffic. So we have studied previous papers and what are the techniques they have mentioned in the paper. So and what is the queue management and congestion avoidance, how they're what in their work they're investigating mechanism for the internet congestion control. In journal, they have used it for red random error detection method, and they have studied for some of the red implementation and identify several structural problems such as producing large traffic oscillations and introducing unnecessary overhead in the fast forwardings. So after coming to the research literature review, after the findings, so I can come with the methodology. What methodology we have used here? Decisions on actions to be taken are based on the current congestion. So AQM technique is the AQM technique is used to identify the congestion and notify the sender about the congestion before it occurs. So it will give the notification before congestion will occur. The notification can send through marking the packets by using ECN bit. So it will mark the packets by using the technique of the ECN bit, and it will drop the packet also. In this case, the router plays an important role for utilization of the resource efficiently. In order to improve the performance of TCP, further mechanism, namely fast congestion notification, FCN, used in this methodology. Many AQM algorithms have been proposed recently to improve the performance of TCP. So coming to the results, we have used the Dumble model simulator in NS2. We have used two routers and two destinations and two sources. Using this, what are the how we evaluated the performance of the parameters? So we have used some parameters. What are the parameters? Means average throughput versus time, and average queue length versus time, and average throughput versus time, and average queue length. These are the parameters we have tested in the simulator. Coming to the average queue length, we present the results gathered from the different AQM techniques. Initially, average throughput is measured from the time to time for the different algorithms. The technique was various. When they compare the techniques, the red is giving more accurate, more results. And coming to the average queue length and versus time, and average queue length in terms of packets is plotted for all. The AVQ maintains very few packets. Different scenarios we have checked, and the graphical versions also we have in the figure. Coming to the average throughput versus time for red variance, the aggregate throughput is measured for the simulation duration for 100 milliseconds. It was shown. It is found from and queue length, average throughput, and packet loss ratio is same for red, GRED, and different techniques. And the average queue length versus time, this also is giving red variants are giving very good results while compared to the other techniques. And the performance, what are the performance while running the simulator? So this is the table shows the results of the different techniques and average what is that capacity of the network, and what is that, how many packets in the queue, and what is the average queue length for the packets, and what is the packet loss ratio. So we have mentioned in the table different algorithms, and what are the values we got in the simulator we have mentioned here. And while we have in red algorithm, we have different sub algorithms also there, especially in the red algorithm. Also we have analyzed that results. Coming to the conclusion part, so we analyze the performance of the several active queue management techniques, namely RED and RIM and GKPA. These are the algorithms. The result shows that RED will perform better than the other algorithms. Also, it shows the RED is able to achieve higher throughput and more stable than the other algorithms. Among RED and its variant, the performance of the NRED is better than the other algorithms. So this is my findings from the paper. This is the references we have taken from this, and thank you very much. If you have any.
University. The topic of my presentation is special ultrasonic cleaning process control. The quality and reliability of the product are directly dependent on the degree of purity. So there are many different cleaning methods used in certain industries. This is a combination of various chemical solvents, manual or mechanical cleaning, as well as ultrasonic cleaning, which eliminated the disadvantages inherent in other methods, such as environmental pollution. Ultrasonic cleaning is one of the most effective in terms of quality and cost. Purification occurs due to the combined action of various non-linear effects that occur in the liquid under the action of powerful ultrasonic vibration. These effects are cavitation, acoustic currents, and sound pressure. The main physical phenomenon that provides ultrasonic clean is ultrasonic cavitation. The implosion of bubbles that occurs under the action of changes in fluid pressure during sonication. This is release of energy which separates the dirt from the body. Cavitation in the ultrasonic bath has a zonal distribution, and it allows to special distributed of the ultrasonic cleaning process. Another factor of this are uneven pollution and uneven separation of part of dirt. There is a set model of ultrasonic cleaning considering special distribution. Cleaning is controlled by using a 3D fuzzy interval controller. The change of arrival time of the signal threshold value and that of the second order nonlinearity coefficient are used as input parameters, which obtained in a p special position. To improve formation of control of ultrasonic cleaning, input parameters include not only intensity values but also those of the ultrasonic beam angle. Thus, cleaning is performed by means of M ultrasonic phased arrays of radiators located in that position and present by intensity coefficient. And according to these coefficients of the ultrasonic beam inclination, P and M are materially independent. To perform the set task, it is necessary to calculate the distance to the focal point and the inclination angle of the ultrasonic beam in direction of the fixed high intensity of cleaning. The distance to the focal point is determined by the arrival time of the signal threshold value to two adjacent sensors, as you see on this slide. The C is the distribution velocity of ultrasound in liquid. T1 and T2 are the arrival time of the signal threshold value to two adjacent sensors. R and alpha are polar coordinate of the radiators. R1 and alpha 1, R2, alpha 2 are the polar coordinators of the sensor adjacent to the radiator. The beam angle is determined by the intensity of the adjacent sensors in the direction of the highest intensity value. Yet, in any case, the inclination angle of the formed beam should not exceed 45 degrees, as this will cause the appearance of lateral petals and deteriorated control efficiency. Therefore, we assume that the control angle is within 0 to 45 degrees and changes in proportion to the ratio of intensity coefficients. The direction in the azimuth plane is determined so that the beam is directed at the half value of the height of the ultrasonic bar. By the described parameters of the ultrasonic beams, we determine the delay time for each element of ultrasonic array. The representation of the coordinate system is shown on this slide. For a transducer located in the position X, for the angular beam from the point F, we have the following time difference. The confirmed efficiency of the developed approach to controlling the ultrasonic cleaning process using a phased array guided by the developed algorithm. This process is simulated by using Huawei. The location of radiator sensors and the contaminated body is present. The cleaned object and contamination are set by the density and velocity of ultrasonic wave propagation. Control efficiency is evaluated by fixing the total of the maximum pressure in the contaminated area. First, the ultrasonic cleaning process is simulated through the direction of the ultrasonic beam into the center of the bath. After that, the resulting field is calculated, which is the total of the beams. Simulation is performed in two stages. Since the first cycle of the treatment forms the basis for assessing the cost of ultrasonic cleaning process. In any case, at the stage, all radiators operate at full capacity. At the second stage, for this case, The cleaning is performed in the direction of the center of the bath with maximum capacity. To transfer capacity to the contaminated area and to reduce power consumption in cleaning section, the algorithm with a 3D fuzzy interval controller is applied to calculating intensities for each radiator. The algorithm described above enables calculating angle for beam redirection. At the first stage, all radiators operate without constraints. After that, the maximum capacity in the contaminated area is analyzed, and where it exceeds the specified value, cleaning occurs. The obtained value of the total maximum capacity is contaminated area amount to 42 Pascal for each stage, while power consumption is 4 multiply 10 to the second power, to the sixth power for each stage for the first approach. And in the second approach, the total maximum capacity in contaminated area near 30 Pascal for each stage, while power consumption is near 2 multiply 10 to the 6th power Pascal. Consequently, power concentration in the contaminated area is improved relative to total power consumption. The increase make 41%. To increase energy efficiency of ultrasonic cleaning, it is necessary to form the control of the highest intensity in the most contaminated area. To determine such areas, ultrasonic responses are analyzed by changes of two parameters, the arrival time of threshold signal and the second order nonlinearity coefficient. The data are used as input 1 and 2 determine the intensity of each radiator using a 3D fuzzy interval controller. However, the control limited by intensity values only does not enable redirection of power distribution to maximize efficiency. Therefore, this research suggests a new approach based on the ultrasonic phase array technology. The intensity obtained at each stage allows calculating the angle for the ultrasonic beam, which is proportionate to the ratio towards the largest intensity. The conducted simulation of cleaning by using the ultrasonic phase array technology reveals a 41% increase in power concentration. Thank you for your attention.
Thank you.
National University Leszek, and I want to present my work automating the work of conveyor line As for the relevance today, it's is difficult to imagine any technological unit without automating system. In the condition of mining and processing plant, automated control systems are used to reduce the use of human power. The development system has improved characteristics in contrast to existing one, which will reduce the cost of using conveyor transport. The present of the HMI panel allows you to control the process directly from the workspace. The following procedure was performed during the work, and its analysis of leading works in the field of automation of conveyor lines, research of existing automated control system to identify weaknesses that need to be eliminated in the design, the choice of software, hardware, and implementation of the scheme according to the task. Conveyor, it's a machine that is designed to transfer goods, namely bulk and artificial. The conveyor is widely used in quarries, mining, and concentrates. In today in today's world, the most common is the use of a belt conveyor, the purpose of which is to transport parts or bulk materials over fairly long distance. Features of a design consist in the following. The main part is represented by a tape of continuous movement which wraps around the guide drums. Second, reducing the degree of deflection of the tape is achieved by installing special rollers. And third, the main element is an electric motor which through the gearbox gives a rotation to the rotating drum. Conveyor line, an integral part of technological industrial lines which combine production cycles, individual shops or high-tech equipment into a single high-performance chain. At large enterprises, the delivery of materials is carried out using a multi-throated conveyor transport line, which consists of printed conveyor lines and prefabricated conveyors, main conveyor lines. The district belt conveyor line provides transportation of material to the main conveyor line. Usually the cargo is reloaded through an intermediate hopper. The main type of conveyor line control at enterprises is automated control. The technical essence of which is to centralize the control of starting and stopping the conveyor line to provide automatic protection against accidents. The mode and condition of the conveyor are the most important parameters for choosing the type of conveyor to be used in the enterprise, and also serve as key parameters for calculating its reliability and strength. The operation of the conveyor is characterized by indicators which are divided into three groups. First, conveyor operation time. Second, load both on the conveyor and on separated elements. And third, features of environment impact and producing condition. The mode of operation of conveyors is a complex characteristic that takes into account the nature of external loads, as well as the intensivity of use of the conveyor. There are 5 modes of conveyor operation. It's very easy, medium, hard, and very hard. And in addition to the distribution of operating modes of conveyor by class of use, generalized operating modes are used for 4 modes. It's operating mode, startup mode, stop mode, and idle mode. There is this slide shows which hardware and software we use to do this work. Hardware is a speed, a sensor, a sorting sensor, the pusher, a controller S7 1200, and program part it's T-Portal and Factory IO. There is this slide shows the control unit for the sequence of control startup. This slide shows a block for controlling the amount of cargo placed and its discharge. This how looks HMI panel for control work. And there is some videos which you can see how the program is work. It's a start of conveyor line. Next, it's the process of conveyor line. And conveyor line stop. In conclusion, conveyor transport automation is the centralization of control of start and stop of conveyor line to provide automatic protection against accidents. To do this, automated control system are equipped with sensors, primary and secondary transducers that transmit process data to a programmable logic controller. The system of automated control of conveyor line begins its work with the supply of voltage by closing the contact M0.0. The control of the work process is performed from the operator panel, which allows you to change the speed of the conveyor line and control the supply of voltage to the system and monitor the condition of the equipment. Thanks for the attention.
Thank you very much. That was a wonderful presentation. By the way, I would like to point that in our university, we have a special Siemens classroom. There, our students, they have an opportunity to prepare these scientific research works. So Nazar just presented one of the results of his work. So let's move forward. Our next speaker should be Olga Soldarenko, but for a pity she can't join us today, so we can speak to skip to another speaker. So Violeta Dmitrieva, supervised by Professor Mikhail Tikhansky. Her speech will be dedicated to automated online control of the weld conveyors using the ITIA portal development environment. So Violeta, please.
Yes, Violeta, I'm student of Kryvyi Rih National University. My paper about automated online control of the belt conveyor using the TIA portal development environment. The software for online control of automated conveyor plant has been developed. The control system allows you to control both the speed of the belt conveyor and the cargo flow. The response to emergencies is also provided. The design system will reduce operating costs and energy resources. With rapid development of automatization system and their widespread implementation, it became possible to influence one of the most important factors, increasing the efficiency and technical level of production. Due to the difficult working conditions, the task of the ACAs is to reduce the use of human power or even eliminate it. To improve working conditions in enterprises, automation of conveyor transport in urgent tasks. The development of automatic control system with the possibility of online control will allow remote control of the belt conveyor directly from the operator side. Belt conveyor, transportation of goods is important link in many technological processes in production. The use of conveyor transport is in demand today. Belt conveyors have become the most widespread due to their high productivity and flexible structure. The main parameters of the belt conveyor are productivity, width, and speed of the belt and engine power. They are responsible for the work. The program is developed in the TIA portal. Execution of functions block takes place in the block main. Node-RED is used to implement online pipeline management. The implementing program provides an opportunity to simulate the emergency simulation of the conveyor for signalization and stopping the conveyor responsible for the unit Ocean control block, Ocean control, which when the alarm stops the conveyor and activates the alarm siren and signal lamps. To calculate the amount of cargo use, the block count is used, which after the operation of the inflamed meter increase the initial number by 1. Block connection to factory EO and about Node-RED. To the use possibility of online control to the pipeline, data from the TIA portal transferred to the local Node-RED project using the built-in library Node-RED contrib S7, and then transferred to the Node-RED cloud project, which implements an operator screen for online control conveyor. On this slide, we watch the user of the Finnish ACS. Is modulation of a variable. In conclusion, through the automatic system of control and visualization of the state of the conveyor and cargo in the online mode in improved version of the existing ones. Conveyor operations is controlled from the local operator panel or from the Node-RED cloud panel, which allows the user to remotely control and always be informed about the status of conveyor transport. Setting the speed range is also an important factor in the operation of automatic system. This function is required for different types of loads and to prevent overshadowing belt shifts or fastening. The program also has the ability to simulate an emergency stop of the conveyor, which is accompanied by siren signalization and signal lamps, as well as sounding and outputting information of the cloud panel. Thanks for attention. That's all.
On the topic automation of water pumping process by pumping station with software development S7-1200 controller. The important component is the development of main working is drainage. Pumping of water from the mains performed by draining pumping station. The operation of the draining pumping station is strongly affected by the inflow of the water, which is not constant during the year. Therefore, pumping to the surface of the water is the main task of the drainage pumping station. The efficiency and productivity of water pumping by the drainage pumping station increases when using the automatic control system. To prevent flooding of mains, there are automatic systems from draining water off the surface, which have disadvantages. The main disadvantages are outdated equipment and the use of outdated software. Therefore, the development of a modern or modernization of the existing system from drainage pumping station is an urgent task. The aim of the work is increase the efficiency of the drainage pumping station through the introduction of modern technological equipment for Siemens and the development of software for the automatic control system on the S7-1200 controller. The single-stage drainage pumping unit is reliable and simple. All water from the mine is pumped to the surface. The main components of the drainage pumping station are pipelines, starter, electric motor, and pump. Supply and pressure are the main parameters of the drainage pumping station, which characterize the pumping modes. By changing their parameters, you can automatically eject the pumping of water from the reservoir by the drainage pumping station. Give the above the system for the visualization of water pumping from the reservoir by the drainage pumping station, which is implemented on the base of the controller S7-1200 in the program portal. Totally integrated automation portal software based on Thematic from Siemens, which forms an integrated working environment for the development of automation project. Tier portal allows you to significantly reduce the cost of configuration and organization of interaction between controllers, drives, and device. Thematic S7-1200 controller are used in the medium and low performance range of the automatic control system to increase efficiency. Thanks to the wide possibility of expansion, a Thematic S7-1200 can be performed perfectly adapted for certain tasks of automation. In this project, the lower level sensor is activated when the water reached 1.5 meters. The upper level sensor is activated at 7.5 meters, and the emergency level sensor is activated when it reaches 9 meters. When the sensor is activated, the light of a certain level lights up. When the emergency level sensor is activated, the emergency light also lights up, informing the operator that this level has been reached. The alarm lights is switched off by the reset alarm button by the operator. The electric motor is switched on after pressing the start button, and its operation is adjusted depending on the water level in the reservoir. When the lower water level is triggered, the electric motor runs at 500 revolutions per minute. At the upper 1000 revolutions per minute, and at emergency 1500 revolutions per minute. When the stop button is pressed, the electric motor switch off. The pump does not run if the electric motor is not running. When the lower water level is the reservoir is pumped out 100 cubic meter per hour. When the upper water level is reached 200 cubic meter per hour. When the emergency level is reached 300 cubic meter per hour. The inflow is displayed after pressing the button that corresponds to a certain water inflow in cubic meter per hour. This slide shows a visualization of the process of pumping water when the lower water level sensor is in the reservoir. When the water in the reservoir reached 1.5 meters, the lower level sensor is activated. After its operation, water is pumped out. The electric motor works at 500 revolutions per minute and pumps 100 cubic meters per hour of water to the surface. The upper level sensor is activated when the water is in the reservoir reached 7.5 meters. The electric motor speed increases to 1000 revolutions per minute and pumped out 200 cubic meters per hour of water. At the level of 9 meters, there is an emergency water level sensor in the reservoir. When it starts, the electric motor speed increases to 1500 revolutions per minute and pumps 300 cubic meters per hour for water from the reservoir. Also, at the operator's place, a light comes on, which informs the operator that an emergency level has been reached. Modernization for the drainage process automation system was performed due to introduction of modern technological means of Siemens and the development of S7 1200 controller software. To ensure continuous operation and avoid accident, the S7 1200 controller software in the TIA-Portal software package was developed, and a visualization system was developed to help track the process of the water pump process. Thanks for your attention.
Thank you very much. Mr. Patel, I think that's it about Ukrainian representatives. So we finished our presentations.